Okay, today we're going to talk about complex numbers. One thing you want to get used to and with video notes is that you're ready to go when the video starts, that you have your notes so you have something to write with, because once I start, you don't want to get left behind. So we're going to talk about complex numbers. We talked about imaginary numbers yesterday. We talked about how imaginary numbers help us take the square root of negative numbers. So anytime you have a negative square root of a negative number, you have to, that'll be an imaginary number. It'll have the I in it somewhere. So complex numbers, a complex number, get situated here, a complex number is the sum of a real number and an imaginary number. And it's usually written in the form of A plus BI. So A is a number, B is a number, but the B has an I portion. Okay, so this A part is the real part. It's the part that doesn't have an I. The B part is the imaginary part. It has the I. Real part, imaginary part. So if we're looking at 3 minus 5i, sum, really you could rewrite that as 3 plus a negative 5i, or you could write 3 minus 5i. Basically, it's a binomial. It's two terms. One's real, one's imaginary. Okay, the 3 is the real part. The 5i is imaginary. Okay. So we're going to talk about adding and subtracting complex numbers, and then we're going to talk about multiplying complex numbers. If I'm adding the complex number 6 plus I and the complex number 4 minus 5i, if you're adding, the sign doesn't change at all. So this is just basically 6 plus I plus a 4 minus 5i. You're just going to combine the like parts. So we can combine the real part. 6 plus 4 is 10. And then we can combine the imaginary parts, just like you would if you were dealing with an x and a negative 5x. If you have a positive I and a negative 5i, that's a negative 4i. And you're done. Okay, this 10 is the real part. This 4i is the imaginary part. Okay, those are the two parts of your complex numbers. So go ahead and try B on your own. I'm going to give you about 10 seconds to get started, and then I will finish up here in a second. Okay. Since it's adding, the sign of the second parenthesis doesn't change, so that's the same as negative 4 plus 2i plus 6 minus 3i. And you just combine like parts, so that negative 4 and a positive 6 are left with a positive 2, and then we have a 2i and a negative 3i. So how many i's will we have left? We'll have one I left, and it'll be a negative. So that reduces to 2 minus I. 2 is the real part. That minus I is the imaginary. Is that what you got? Pretty easy, hopefully. If now you have questions, you can raise your hand, ask the sub, see if they can disclose anything or clarify anything. The next thing we're going to talk about is subtracting. How to subtract 2. If you have a negative sign in front of a parenthesis, it's like you have a negative 1, and you have to distribute that negative part across your parenthesis. Okay, so we have an 8 plus a 3i, and then negative 1 times 6 is a negative 6. Negative 1 times negative 2i is a positive 2i. So you just have to be careful to distribute the negative 1 to change the signs, and then you can combine your real parts. A positive 8 and a negative 6 leave you with a positive 2, and then that 3i and the 2i combine to be 5i. Your real part is the 2, your imaginary part is the 5i. Okay, why don't y'all try D? I'll give you about 10 seconds to get a head start, and then I'll finish it up. And if the sub needs to pause it for extra time, y'all can have some extra time. When you have two things being subtracted, you have to distribute that negative sign to that second parenthesis. The first parenthesis doesn't change. It stays a 5 minus an I. Negative 1 times 3 is negative 3. Negative 1 times a negative 2i is a positive 2i. Okay. From here, the next thing we're going to do is 5 and a negative 3 leaves you with a positive 2. And negative I and a positive 2i leaves you with a positive 1i. There's the real part. There's the imaginary part. Okay, feeling pretty good? Okay, try the last two. Sub, you can pause it right now. I'm going to keep on going. I want them to try the last two individually, and then we can check it all. So if you'll pause the video. On this one, you should get 6 minus 3i plus 4 minus 2i. You combine your i's, you combine your real numbers, you should get 10 minus 5i. Here you need to distribute that negative, so it's a negative 1, positive 5i. The front parenthesis stays the same. So we're going to have 9 i's and then negative 11 and a negative 1. Which makes it negative 12. So negative 12 plus a 9i. Hopefully that's what you guys got. If you have questions, ask the sub. Moving right along, we're going to move to multiplying complex numbers. Okay, so instead of having an addition or subtraction sign, you have a little dot. That's a multiplication sign. Okay, we're going to simplify and then identify the real and the imaginary part. Okay, so when we're multiplying two parentheses, just like two binomials we FOILed, we did the first term, 2 times a negative 4 and 2 times a 2i. So 2 times negative 4 is a negative 8. 2 times 2i is a positive 4i. Then we're going to distribute that second term in the first parenthesis. So negative 5i times a negative 4, negative times a negative is a positive, so positive 20. And then you have the I. And then a negative 5i times a 2i is a negative 10i squared. Now, yesterday we talked about all the things, properties of i's. We talked about that how I was the square root of negative 1. So you need to remember this. Remember. Go ahead and write this down if you haven't already. You want to remember that I is equal to the square root of negative 1. I squared is always, what did we talk about yesterday? It's always negative 1. And then we talked about how I cubed was the same as a negative I. Okay, we'll need some of that today. Okay, so here, when I'm simplifying, I can combine these i's, because those are like terms. That negative 8 in front is going to stay the same. This 4i plus 20i is a positive 24i. And then you have a negative 10i squared, which a negative 10i squared is the same as negative 10 times a negative 1. What's negative 10 times negative 1? It's a positive 10. Okay, so this negative 10i squared changes to a positive 10. And now we combine the negative 8 and the positive 10. So we have negative 8 plus 10 is a positive 2. So our answer should be 2 plus 24i. The 2 is the real part, and the 24 is the imaginary part. Okay, any questions there? Okay, let's look at this one. We're going to multiply these two. If you feel pretty comfortable with foiling, you can try it ahead of me. If not, you can wait for me to catch up. So we have 2 times the first term and the second term in the second parenthesis. 2 times 3 is 6. 2 times a negative I is a negative 2I. You have I times 3 and I times a negative I. I times 3 is a positive 3I. And I times a negative I is a negative I squared. Okay, we can combine our i's. So that 6 out in front is going to stay. What's a negative 2I plus 3I? That's going to be a positive I left. Okay, if you have a negative I squared, that means you have a negative negative 1. What happens when you have a negative negative 1? It turns into a positive 1. So now we can combine that positive 1 and that 6, which makes it 7. You always write the real part first and then the imaginary part. So that number is 7 plus I. 7 is your real part, I is your imaginary part. Okay. Again, I want you to try these two on your own. So Seb, if you'll pause the video, let them try these two on their own, and then come back to check if they got it right. Hopefully after you've paused it. We're going to distribute 5 times 4 and 5 times a negative I, so we get a 20. 5 times negative I is a negative 5I. A negative 2I times 4 is a negative 8I. And negative 2I times a negative I is a positive 2I squared. We can combine our i's. A negative 5I and a negative 8I is a negative 13I. You have that 20 out in front. 2 times an I squared is the same as 2 times negative 1, so that changes to a negative 2. So now we can combine the 20 and the negative 2. 20 minus 2 is 18, so our answer is 18 minus 13I. 18 is the real part, 13 is the imaginary part. Questions there? Okay, let's talk about J. Distribute that 4 times 1, 4 times negative 2. 4 times 1 is 4. 4 times a negative 2I is a negative 8I. We have negative 2 times 1, and negative 2 times negative 2I. Negative 2I times 1 is a negative 2I. Negative 2 times a negative 2 is a positive 4. I times I is I squared. We can combine our i's. A negative 8I and a negative 2I is a negative 10I. We have that 4 out in front. 4 times I squared is the same as 4 times negative 1, so that 4 will become a negative 4. And then we can combine the 4 and the negative 4. What happens when you combine a 4 and a negative 4? It's just a negative 10I. And if you're writing, you can leave it as negative 10I. This is the imaginary part. What's the real part? Okay, the real part would be the 0 in front. That would be the real part. You could either leave it 0 minus 10I, or you could leave it minus 10I. I'm not going to be picky about that. Okay, questions on that? The last thing we're going to talk about is conjugates. Okay, the conjugate of a complex number has the same real part, so the real part stays the same, but it's going to have an opposite imaginary part, which means you change the sign of the imaginary part. Okay, so this is what we're going to do next. Here, the complex conjugate, or the complex number, is 2 plus 3i. So the complex conjugate, all it's going to do differently is make the imaginary part, the part with the I, have a negative number instead of a positive. That's all you're doing. So if this is the imaginary number they give us, and they're asking for the conjugate, well, our conjugate, what's the imaginary part? The imaginary part is that negative 2i, so we're going to change it to a positive 2i, and the real number, or the real part, stays the same, so it'll be 4 plus 2i. That's it. On this one, you had a negative 3 plus 6i. You change the sign of the imaginary part, so it'll be a negative 3 minus 6i. The real part doesn't change, the imaginary part changes. Okay. Try M and N on your own. Complex conjugate for this is a negative 12 plus 5i. the complex conjugate for this, the 2/3, don't let the fractions throw you off, no big deal. 2/3 is the real part, the imaginary part is the part with the I, so we'll change that to a positive 5/2I. Okay, the last thing we're going to look at is complex conjugates have a special property so that when the complex conjugates are added or multiplied, the result will have an imaginary part of 0I. So if you multiply like this 3 minus 2I and this 3 plus 2I, the imaginary part will cancel out. And actually what we're going to do, we're going to add one and then we're going to multiply one. So on this case, I want you to insert a plus sign. So we have a 3 minus 2I plus a 3 plus 2I. Those are both complex conjugates because this has a negative imaginary part and it's the exact same thing except this one has a positive. When we add those two together, your 3 plus 3 gives you 6. When you combine a negative 2I and a positive 2I together, the imaginary part cancels, and so it has an imaginary part of 0I, or you could just say it's a real number. Okay, when we multiply the conjugates, complex conjugates, when we add them, it gives us a real number. When we multiply them, and you distribute it, now this is a negative 4 plus 6I and a negative 4 minus 6I, so those are complex conjugates. Okay, the imaginary part changed signs and the real part stayed the same. You can distribute that negative 4. Negative 4 times negative 4 is a positive 16. Negative 4 times a negative 6 is a positive 24I. This 6 times a negative 4 is a negative 24I. And 6 times a negative 6 is a negative 36I squared. Okay, then 24I and the negative 24I, they'll cancel each other out. So we're left with 16. That negative 36 times I squared is the same thing as negative 36 times a negative 1. So that turns into a positive 36. And we add 16 plus 36, we get 52. So again, the imaginary part is 0 I's. You have no more I's left. So that's our real number. That's our real part. Okay. Your assignment that goes with this is fairly short. Y'all hopefully should be able to finish it today. If it's not finished today, today's Tuesday, it's due at the beginning of class on Thursday, so you'll have some time on Wednesday, but we're jumping into quadratic formula on Wednesday. And that's a lot of new stuff, so you'll want to stay ahead of the game if at all possible. This is what your assignment looks like. It says complex number assignment. It asks you to simplify, so the first thing you're going to do, just like we did on the front of this, we just simplified, so we added them together and simplified it. And then on all of these, it'll ask you for the complex conjugate. So you give me the original version, and then you give me the conjugate. That's on all of them. So they're just adding, subtracting, multiplying, dividing. You have 10 problems. Iron Mark, set, go.